to talk about the principal square root, because this can be something that is a little confusing at times. So in mathematics, if we have the square root of something, like the square root of 25, then the answer is only positive 5. It's called the principal square root. It's only positive. But if you had started off with an equation like x squared equals 25, and then you had to take the square root of both sides, you might remember teacher saying, well, you have to add a plus or minus in front of that, because the answer could be plus 5 or minus 5. So if you start off with x squared equals 25, it makes sense that 5 times 5 is 25, and also negative 5 times negative 5 is 25, and there would be two answers. But when we're just working with the square root, mathematics says that's only positive 5. That's why the plus or minus is in front, because this itself is only positive 5. And that becomes important, and you can even put a highlighter box around this, is because there's a very common mistake in math, which doesn't seem like it should be wrong, but if someone says, what's the square root of x squared? And the common mistake is they say it's x. And that's mostly right, but not always right. And the reason for this is because what if you had started with a negative number inside? The square root and the squared can't cancel out. This doesn't just equal minus 3, because square roots are always positive in the end. That's the principal square root. If you did order of operations, you would first say, well, negative 3 squared, that's 9. And what's the square root of 9? It's positive 3. And this is another application of square roots. So we would say that the square root of x squared is the absolute value of x. That makes it positive in the end. Notice that had we put that minus 3 in absolute values, then we would have got 3 and got the right answer anyways. So square rooting and squaring are opposites, and usually opposites cancel each other out. But sometimes, as in this case, it doesn't work out that nicely. Because of order of operations, if there was a negative in there, then it becomes positive. So when we get to example 3 here, we'll do it very quickly. We'll sort of do a quicker way and a little bit longer way. If you want to do it the quick way and say, hey, my square root and my squared are going to cancel out, then you have to write your answer in absolute values. And if I do that, I'm like, oh, 7 minus 10 is negative 3. My answer is positive 3. That's quick because you just quickly canceled something out. The longer way isn't much longer. The longer is actually simplifying. So 7 minus 10, that's negative 3. And negative 3 times negative 3, that's positive 9. And the square root of positive 9 is positive 3. It's not really much longer if we look at how much I had to write. It's almost identical. But it could be, right? It could be a little bit more difficult if the number inside wasn't easy, like minus 3 times minus 3 was 9. If this ended up being minus 115, I don't think I'd want to square that in my head. So it could be longer in those situations. So square roots and squaring cancel each other out. That's really nice. But because the square root's always positive, when we cancel it out, to be certain we haven't made a mistake, we add the absolute values. Sometimes it doesn't matter, right? If it was 10 minus 7, you wouldn't need the absolute values because then it would have been positive 3 anyways. But if the answer ends up negative, we have to make it positive, and we can show that by doing the square roots. Okay, so I'm going to get you to circle questions 6, 10, and 11.